Chapter 5, Elasticity and its Application. The elasticity chapter in most principles textbooks is fairly technical, and it's not always the student's favorite. However, this PowerPoint chapter contains several special features designed to engage and motivate you to learn this important material. First, we consider a scenario in which you face a business decision, whether to raise the price of a service that you sell. In this scenario, we use this scenario to illustrate the effects of raising a price on the number of units sold and on revenue, which hopefully you will immediately recognize as critical to any business decisions. Second, instead of merely listing the determinants of elasticity, you're asked to think about some concrete examples and deduce from each one a lesson about the determinants of elasticity. And thirdly, instead of putting the applications at the end of the chapter, as in the textbook in your reading, this presentation is going to include them immediately after the section on price elasticity of demand, which helps break up what would otherwise be a long stretch of just theory. Other than that, please be assured that this video lecture is nonetheless very consistent with the textbook's approach. And again, it's paramount that you do the reading in addition to the lecture. So in this chapter, we're going to look to answer the following questions. What is elasticity? What kind of issues can elasticity help us understand? What is the price elasticity of demand? How is it related to the demand curve? How is it related to revenue and expenditure? What is the price elasticity of supply? How is it related to the supply curve? And lastly, what are the income and cross-price elasticities of demand? So let's start out with a scenario. We'll follow this scenario throughout the first section of this chapter, the section on price elasticity of demand, to illustrate and motivate several important concepts such as the impact of price changes on sales and revenue. So let's say in this scenario you design websites for local businesses. You charge $200 per website and you currently sell 12 websites per month. Your costs are rising, including the opportunity cost of your time. So you consider raising the price to $250. The law of demand says that you won't sell as many websites if you raise your price, but how many fewer websites will you sell? We know if price goes up, people are going to want less, but how much less? How much will your revenue fall, or might it increase? It's an interesting question. But before we get there, let's figure out what elasticity is. The basic idea of elasticity is that elasticity measures how much one variable responds to changes in another variable. One type of elasticity measures how much demand for your websites will fall if you raise your price. For definition purposes, elasticity is the numerical measure of the responsiveness of quantity demanded and quantity supplied to one of its determinants. So how does the quantity demand and how does the quantity supply change if something like, say, price changes? Here is the very simple equation for price elasticity of demand. It's simply the percentage change in quantity demanded over the percentage change in price. You have some sort of change in price. You want to see how much your quantity is going to change, and we do this in percentage terms. So price elasticity of demand measures how much quantity demanded responds in a change in price. How much quantity demanded changes up or down when you change your price. Loosely speaking, it measures the price sensitivity of a buyer's demand. One example, and this is just, we're given the rise over run here in this very simple example. Price elasticity of demand equals when price rises by 10%, that's our percent change in price, and quantity falls by 15%, that's our percent change in quantity demanded. It's simply 15% divided by 10%, and our price elasticity is 1.5. Along a demand curve, price and quantity move in opposite directions. Again, remember this is a demand curve. If something becomes more expensive, people are typically going to want less of it. So as along the demand curve, price and quantity move in opposite directions, which would make price elasticity negative, which makes sense because the demand curve is negatively sloped. We will drop the minus sign, the negative, and report all of these elasticities as positive numbers. Again, it's worth noting P and Q move in opposite directions, which means the percentage change in quantity and percentage change in price will have opposite signs, thus implying a negative price elasticity when you think about the ratio. To be consistent with the text, the last statement in the green box says that we will report all elasticities as positive numbers. It's really better just to say as absolute numbers. It might be slightly more accurate to say that we report all elasticities as non-negative numbers. We want to allow for, albeit rare, admittedly rare case of a zero elasticity. So calculating percentage changes, we look at the standard method of computing percentage change, which can be a little bit cumbersome. You simply take where you end up, the end value, and minus where you started, the start value, and divide by the start value. You want to see how far you came from the start value, and you need the difference between the end and start value divided by the start value, multiplied by 100 just to get a percentage terms. And going from A to B on the graph you see here, the percentage change in price equals, you started out at 200 and you ended up at 250, so 250 minus 200 divided by where you started out is 25%. The problem here is the standard method gives different answers depending on where you start. From A to B, price rises by 25%, quantity falls by 33%. Elasticity then would be 33 divided by 25 equals 1.33. However, if you move from B to A, price falls by 20%, quantity rises by 50%, then your elasticity would be that quantity over price percentage change would be 50 divided by 20, and elasticity would be 2.5. This can be pretty confusing if you don't pay close attention to where your start was and whether you're moving from A to B or B to A. However, to avoid this, we use what's called the midpoint method when calculating percentage changes. We simply take the end value minus the start value, nothing's changed there. However, instead of dividing by simply the start value, we take the midpoint. The midpoint is the number halfway between the start and end values, the average of those values essentially. So if you remember in our previous example, the start value was 200 and the end value was 250. The midpoint would be 225. It doesn't matter which value you use as the start and which is the end, you get the same answer either way. So this deals with that cumbersome problem when you use a standard calculating percentage change issue of where you start, whether you go from B to A or A to B. This addresses that issue. So using the midpoint method, the percentage change of price equals 250, the end value minus the start value of 200, and then we divide by the midpoint and then convert it to percentage terms, and we get 22.2%. Again, this is just for the percentage change. This isn't the elasticity calculation yet. The percent change in quantity, the first one was a percent change in price. Now we look at percent change in quantity. In value, we had a quantity demanded of 12 and a start value of 8. So 12 minus 8 over the midpoint, which is 10, and then convert that percentage terms, and you had a 40% change. So you have a 22.2% change and a 40% change. The price elasticity is that quantity percent change, quantity demanded percent change, over the percent change in price, 40 divided by 22.2, and you get a much more solid elasticity figure of 1.8. Again, these calculations are based on the previous example given. So let's work on a problem here. Calculate elasticity. Using the following information to calculate price elasticity of demand for hotel rooms, if the price is $135 for a hotel room, quantity demand is 8,600 hotel rooms. And then if the price is $165, quantity demanded is 7,400. So the price went up, quantity demanded went down. We know that from the supply and demand chapter. That makes perfect sense. So essentially we're seeing a price change here from 135 to 165. So we're going to apply our midpoint method here to calculate the percentage change in quantity demanded. 8,600, the end quantity demanded, and minus 7,400 divided by the midpoint, which is 8,000, is 15% change. So again, notice here that the ending quantity demanded is 8,600, the starting quantity demanded is 7,400. So obviously we must be talking about a price decrease here from 165 to 135. The percent change, again, the percent change in price, 165 to 135 divided by 150. The midpoint again is 150 of 20%. Price elasticity of demand equals the 15% change in quantity demanded over the percent change in price, and the elasticity value is 0.75. Okay. This is just simply to show you how to calculate it. I'm going to show you here in a bit what these calculations mean. And actually, I think I may have just misspoken. This is the end value is 165 in terms of price, so that it was a price increase from 135 to 165. My apologies. But in terms of the point of this exercise, it's just to show you how to calculate it. So hopefully that is apparent there. So what determines price elasticity? To learn the determinants of price elasticity, we look at a series of examples. Here, hopefully, we can start to put some meat on the bones of the calculations that we just did in terms of what elasticity means. So in each example, suppose the price of both goods rise by 20%. The good for which quantity demanded falls the most in percent has the highest price elasticity of demand. Which good is it and why? What lesson does this example teach us about the determinants of price elasticity of demand? In essence, the textbook says here are the determinants of elasticity. The first one is availability of close substitutes. Here's an example, so on and so forth. That's great for a textbook, but on the next few slides, we're going to deduce the general lessons from specific examples. So hopefully you can figure things out using common sense. Essentially, elasticity is how much you're going to change your buying habits. Say you really like Skittles, and the price of Skittles goes up. If you're really a big fan of Skittles, while you may decrease your consumption of Skittles, you may not decrease it as much as someone who's only a marginal fan of, say, Skittles. So if there's a candy or something that you like and it doubles in price in the vending machine, you still like that candy. You're going to consume some, but if it doubles in price, you're going to consume a good bit less. It's just how much less. That how much less is essentially what we're talking about here when we talk about price elasticity. How much less will you consume? So you will consume less. Your classmates will consume less. Everybody will consume less. Some will go all the way down to none. Some will cut it in half. Some will just eat one less candy bar a week. And all those add up to the overall change in the quantity demanded given a price change. So let's go through some examples. Here we have breakfast cereal versus sunscreen. Now what they're doing here is two very different types of products to try to illustrate two very different types of elasticity. The prices of both of these goods rise by 20%. Say there's some sort of flat inflation on prices. For which good does quantity demanded drop most? This says a lot about their elasticity. They have different elasticities because they're different products. And why? Breakfast cereal has close substitutes. For example, pancakes, Eggo waffles, leftover pizza. So buyers can easily switch if the price rises. Sunscreen, on the other hand, has no close substitutes. So a price increase will not necessarily affect the demand as much, or at least very much. What's the lesson here in this thought experiment? Price elasticity is higher when close substitutes are available. When there's something you can switch to, you tend to have a higher price elasticity, which basically means your response to price changes. You have a higher response to price elasticity, changes when there's something that you can easily substitute for. Example 2, blue jeans versus just clothing. The price of both goods rise by 20%. For which good does quantity demanded drop the most and why? For a narrowly defined good such as blue jeans, there are many substitutes. Khakis, shorts, Speedos, hopefully not in my class, but whatever. Whatever floats your boats, folks. However, there are fewer substitutes available for broadly defined goods. Just clothing in general. There's really, especially in my class, no alternative to not wearing clothes. Are there any substitutes for clothing? Not really. Price elasticity is higher for narrowly defined goods than broadly defined goods. So the more specific you are, I can replace just wearing blue jeans. I can wear khakis, whatever. But just clothing in general, there's less price elasticity. So the nature of this thought experiment, you're looking at two alternative scenarios here. In the first, the price of blue jeans and no other clothing. So specifically, blue jean rises by 20%. We would observe the percentage decrease in quantity of blue jeans demanded. In the second scenario, the price of all clothing rises by 20%. We observe the percentage decrease in demand for all clothing. Perhaps people wear older clothing longer. However, in general, people are going to have to replace clothes as they wear out. If blue jeans continually had a price increase over time, people would just find substitutes for blue jeans. Something like insulin, say for diabetics versus Caribbean cruises. The price of both these goods rise by 20%. For which good does quantity demanded drop the most and why? To millions of diabetics, the insulin is a necessity. A rise in its price would cause little or no decrease in demand. They still need it to function, to be healthy, to keep their sugars under control. A cruise is a luxury. If the price rises, some people will forego it. They'll just go do something else with their free time. Lesson here, price elasticity is higher for luxuries than for necessities. So necessities are necessaries, things you have to have. So there's the demand for that's not going to change as greatly as it would for a luxury. For luxury, if price goes way up, you just find a new luxury. Example 4, gasoline in the short run versus gasoline in the long run. The price of gasoline rises by 20%. What does quantity demand drop? Which quantity demand drops more in the short run or the long run? Why? There's not much people can do in the short run other than ride a bus or a carpool. In the short run, you're pretty much stuck kind of commuting how you commute, especially in an area like where we live, in a more rural state. In the long run, people can buy smaller cars or live closer to work. Takes a while to sell your house and move closer perhaps to work or to school. To come up with other alternatives like saving up to buy a hybrid, that's more of a long run deal. Therefore, the lesson here is price elasticity is higher in the long run than it is in the short run. That's pretty much true of anything. In the long run, everything's variable. In the short run, there are some things that are just fixed costs and fixed investments. So, the determinants of price elasticity, a summary. Again, this is just overall price elasticity. Price elasticity of demand depends on the extent to which close substitutes are available. Are there alternatives? If there are alternatives, price elasticity is going to be higher. There's going to be more movement in quantity demanded when a price changes. Whether the good is a necessity or luxury, necessity is pretty much going to stay the same. Quantity demanded for luxury can vary widely given the price change. How broadly or narrowly the good is defined. Remember the blue jeans versus clothing. And the time horizon, is it long run, short run? Elasticity is higher in the long run than it is in the short run. You can make a lot more changes in the long run than you can in the short run. So let's get back to demand curves here. The price elasticity of demand is closely related to the slope of the demand curve. Remember the rule of thumb, the flatter the curve, the bigger the elasticity, the steeper the curve, the smaller the elasticity. Now if you think about that as a thought experiment, and we're going to show some demand curves here in a second, but a flatter curve would cover a more wide range of quantity on that horizontal axis, and a more steep curve would cover a less wide range of quantity on the horizontal axis. So just keep that in mind. We're going to illustrate it right here. Economists generally classify demand curves according to their elasticity. The next 5 slides present 5 different classifications from least to most elastic. So least elastic to most elastic. This is a perfectly inelastic demand curve. Again, I want you to concentrate here on the graph. Perfectly inelastic demand curve. There's no variation in quantity here. There's no wide range in quantity. Quantity changes by 0% when price falls by 10%. The demand curve is vertical, and the consumer's price sensitivity is none. It's just elasticity is 0. This is that rare case where we talk about elasticity 0. In more inelastic products, think of like the insulin. An insulin or a diabetes patient needs a certain amount of insulin a day. They certainly don't want to take too much, but they have a minimum that they need, so that's a pretty inelastic demand. If quantity doesn't change, then the percentage change in Q equals 0, thus the elasticity is 0. It's hard to think really of a good in which the price elasticity is literally 0. Perhaps the insulin example. Sufficiently large price would probably reduce the demand for insulin a little, particularly among people with very low incomes or no health insurance. However, if elasticity is very close to 0, then the demand curve is almost vertical. This is the extreme case where the demand curve is vertical. Again, we're moving from least to most elasticity. In such cases, the convenience of modeling demand as perfectly inelastic probably outweighs the cost of being slightly inaccurate. So here's a fairly inelastic demand. We see a bit of a curve, demand curve, which is really more realistic in real life instead of the linear demand curve. The demand curve is relatively steep. The consumer's price sensitivity is relatively low. You can see the big change in price here didn't result in a huge change in quantity. Price falls by 10%, quantity rises by less than 10%. So the price fall was bigger than the quantity increase, so it's a relatively inelastic change. The elasticity is less than 1. So if you have elasticity is less than 1, you can say it's inelastic demand. An example would be student demand for textbooks that the professors have required for their courses. Here it is a little more clear that elasticity would be small, but not 0. At a high enough price, some students will not buy their books, but instead will share with a friend or try to find them in the library, or just make copies or copious notes in class. Another example would be gasoline in the short run. You just need a certain amount of gas in the short run. So just remember, an elasticity of less than 1 is inelastic. And you should know how to graph it as well. Fairly inelastic demand. This is called unit elastic demand, the next example. Elasticity equals 1. This is the intermediate case. The demand curve is either relatively steep or is neither relatively steep nor relatively flat. It's somewhere in between. Buyers are neither relatively price sensitive nor relatively insensitive to price. This is also the case where price changes have no effect on revenue. So price falls by 10%, quantity rises by 10%. If they're equal, the 10% over 10%, and elasticity is 1, you can call it unit elastic. So less than 1 inelastic, equals 0 perfectly inelastic, less than 1 inelastic, equals 1 is unit elastic. Now here's elastic demand. Okay, the demand curve is relatively flat. Consumers' price sensitivity is relatively high, and elasticity is greater than 1. So we had a price change that fell. The price fell by 10%, but the quantity rose by greater than 10%. So there was a significant reaction to the price change. Here in this example, price goes down, quantity goes really high. This is a product of a very elastic demand curve. As the demand curve becomes more horizontal, it covers a greater quantity in when price changes. So if price was here and you have a flat curve here, price goes down here, quantity jumps not just a little but a lot. This is a good example of this would be breakfast cereal, or nearly anything with readily available substitutes. An elastic demand curve is flatter than a unit elastic demand curve, which itself is flatter than an inelastic demand curve. So as you can see, we've worked from a vertical to a more elastic to a unit elastic to an elastic demand curve. So elasticity greater than 1 is a elastic demand. Now let's look at the other extreme case. A demand curve that's horizontal. Consumers' price sensitivity is extreme, elasticity is infinite. Price changes by 0%, quantity changes by any percent. Extreme price sensitivity means that the tiniest price increase causes demand to fall to 0. So price goes up to here, it goes to 0. There's no demand. It won't hit demand anywhere. Pardon me. Quantity changes by any percentage. when the demand curve is horizontal, the quantity cannot be determined from price. Consumers might demand Q1 units for 1 month, Q2 units for another month, and some other quantity later. Quantity can change by any amount, but price also changes by 0%. In other words, it doesn't change. Price is pretty much set. And if perfectly inelastic is one extreme, this case perfectly elastic is the other. So we started with the perfectly vertical demand curve, which is sort of unrealistic, and now we have a perfectly horizontal, which is another unrealistic situation. A good real-world example of perfectly elastic demand curve like you see here, which foreshadows an upcoming chapter on firms in competitive markets. Suppose you run a small family farm in Iowa. Your main crop is wheat. The market demand curve in this market is downward sloping. The market demand and supply curves determine the price of wheat. Suppose that price is $5 a bushel. Now consider the demand curve you're facing. As an individual wheat farmer, if you charge a price of $5, you can sell as much or as little as you want. It just depends on how much wheat you can produce. If you charge a price even just a little higher than $5, demand for your wheat will fall to zero. Why? Because you're just a small farmer out in Iowa. They can buy wheat from anyone. The market can buy wheat from anyone in the Midwest or South or wherever. Buyers will not be willing to pay you more than $5 when they could get the same wheat elsewhere for $5. If you drop your price below $5, then demand for your wheat becomes enormous. Not literally infinite, but almost infinite. They'll buy every bit that you have. If other wheat farmers are charging $5 and you charge less, then every buyer will want to buy wheat from you, and you won't be able to handle the demand. But if you think of it logically, as a producer, why would you want to sell for lower than market price? You'd be leaving money on the table when you can sell all your wheat at $5 anyway. So why is the demand curve facing an individual perfectly inelastic? Well, recall that elasticity is greater when lots of close substitutes are available. In this case, you're selling a product that has many perfect substitutes, identical products. Remember that perfect substitutes scenario? The wheat sold by every other farmer is a perfect substitute for the wheat you sell. So if you charge higher, you won't get any business. If you charge lower, you will sell your wheat, but you will have left some money on the table, which means you're not making as high of a profit as you could have. So here are a few elasticities in the real world. You see some lower services and goods moving up to some higher ones. Few substitutes for eggs, healthcare, and rice. And then you start to look at things like restaurant meals and Mountain Dew. There's great substitutes for different restaurant meals and Mountain Dew. You can cook at home. Mountain Dew, you can simply switch to Sprite or do something else. So there's different alternatives, more alternatives when you have a higher elasticity, and lower alternatives when you have a lower elasticity. This slide corresponds with the FYI box in the textbook. And the estimates are from various studies, and the textbook actually goes into greater detail, but these are a good illustration for this lecture presentation. So let's look at elasticity of a linear demand curve. The slope of a linear demand curve is constant, but its elasticity is not. Remember when we first started talking about elasticity in this presentation, it was a pretty linear curve that we're looking at movements from B to A and A to B, and depending on which one you did first, the percentage change changed. Well, the linear slope of demand curve is constant, but again, the elasticity is not necessarily constant. Due to spatial limitations, this slide uses E as an abbreviation for elasticity. The calculations shown on the slide use the midpoint method. As you move down the linear demand curve, the slope remains constant. You can verify this by calculating the slope between any 2 points and any 2 pairs of points on the line. So you can go through and verify the calculations you see on the slide. However, the percentage change between the pairs of points vary, so the elasticity varies. The calculations shown on the slide confirm that elasticity falls as you move downward and rightward along the linear demand curve. So for a little more intuition there, you can check out the textbook, which goes in a little more detail. However, actually, I'll just read directly from the textbook. The explanation for this fact comes from the arithmetic of percentage changes. when the price is low and consumers are buying a lot, a $1 price increase and a 2-unit reduction in quantity demanded constitute a larger percentage increase in the price, again, because your base is smaller, you're buying lower amounts. A small percentage decrease in quantity demanded resulting in small elasticity. By contrast, when the price is high and consumers are not buying as much, the same $1 price increase and a 2-unit reduction in quantity demanded constitute a small percentage increase in the larger price and the larger percentage decrease in the quantity demanded, resulting in a larger elasticity. Please note also that the most elastic portion of the demand curve, with the buyers have relatively few units and a high willingness to pay for additional units. As buyers acquire more units, and their willingness to pay for additional ones falls. So does the price elasticity of demand. Well, that just makes sense. As you consume more of a good, you kind of want less of that good. I'm a big fan of pizza. However, when I get to about the 3rd or 4th slice, I'm not as big a fan of pizza as I was around the 1st or 2nd slice. So as you consume more, the quantity demanded falls. That's called marginal utility. We'll get there eventually. So let's take a look at price elasticity and total revenue. Continue with our scenario. If you raise your price from $200 to $250, this is our website business again, would your revenue rise or fall? So we all know that you simply get revenue by taking the price you charge, multiplying it by the quantity. Again, this is revenue, not profit, so we're not considering cost here. It's just total revenue. A price increase has 2 effects on revenues. The higher price means more revenue for each unit you sell. But we all know if you raise your price, you're probably going to sell fewer units. But you sell fewer units, lower Q, due to the law of demand. So these 2 things work against each other. Which of these has which of these 2 effects is bigger? Because that'll determine what happens to your revenue. It all depends on the price elasticity of demand. So we go back to our website scenario here. This shouldn't be hard for you to imagine yourself in this position. You're running your own business and you're trying to decide whether to raise the price or not. What will it do to your revenues? It should be clear that making the best possible decision would require information about likely effects on the price increase or revenue. That's why elasticity is so helpful. So we'll try to illustrate that now. So depending on what your price elasticity is, you won't be able to answer the question of which of these 2 effects is bigger, and thus tell me whether the revenue goes up or down. So again, looking at price elasticity of demand and considering what revenue is price times quantity. If demand is elastic, then the price elasticity of demand is greater than 1. A percentage change in quantity is going to be bigger than the percentage change in price. Thus, we know that the quantity will go down a greater amount. So the fall in revenue from a lower quantity is greater than the increase in revenue from a higher price. So revenue falls. So it's more elastic. People react. They cut back more on your product, and your increased price will not make up for the decreased quantity. Again, using the example of an elastic demand, let's say 1.8 that we calculated with the midpoint method earlier in the presentation. If the price is $200, quantity is 12, and revenue is $2,400, 200 times 12. If price is $250, quantity is 8, and revenue is $2,000. When demand is elastic, the price increase causes the revenue to fall. That's the calculation portion of it. Increased revenue due to the higher price, you see here in yellow. You went from 200 to 250. Again, before you were selling websites at $200 with this demand curve, and you were selling 12 websites, I believe it said a month. So 200 times 12 with this overall box right here. Okay, that was your revenue. Okay, 200 times 12, the revenue was this overall space, this green and blue area here. Okay, so what you did now is you raised your price to 250 with this demand curve, and your quantity went down to 8. Okay, so you lost 4 websites a month. So 250 times 8 is this green and yellow box here. So how you tell whether or not you made money or not, at least in terms of the graph, is you look at the spaces. Now before, this whole rectangular rectangular area here was your revenue. Okay. Well, when you went to 250, it changed to this more vertical rectangle. Okay. Well, what did you gain and what did you lose? Well, the yellow area is what you gained. You didn't have this before. However, what you gave up was this blue area. You went from this rectangle that I'm outlining here to this rectangle here. Well, what's bigger, the yellow area that you gained or the blue area that you lost? Well, obviously the blue area is bigger. You lost more there. So graphically you can do it. You can obviously calculate it. If you're given the elasticity, you'll need to be able to do both. But even my little 3-year-old daughter could say, hey, Daddy, this area is bigger than this area. If this is the loss, it's bigger than the gain. So your revenue went down. All right, so continuing this discussion, if demand is inelastic, okay, before we're dealing with an elastic demand, the price elasticity of demand is less than 1. So percentage change in quantity is less than the price change, okay? So we talked about elastic. We talked about elastic. Let's talk about inelastic. The fall in revenue from the the fall in revenue from a lower quantity is smaller than increase in revenue from the price. So here we're dealing with a fairly inelastic demand for websites, so it's a more vertical demand curve. In this example, suppose quantity falls by only 10 instead of it falls to only 10 instead of the 8, so it went from 12 websites a month down to 10 instead of going from 12 to 8 in the previous example. We'd be dealing with a very different demand schedule when you raise your price to 250. So what does this mean? All right, let's do the left first, and then we'll go to the right. Now the demand is inelastic. Let's say you're given or calculated an elasticity of 0.82. It's less than 1, so you know it's fairly inelastic. You can see here the demand curve is more vertical. Before it was more flat. If price is equal to 200 and quantities 12, your revenue is 2,400. That's the same as before. If price is 250, you raise your price to 250. Then you only sell 10 a month. Revenue is 2,500. Now what happened there? Quantity went down, but revenue actually went up by $100. That's because the demand was inelastic. A price increase actually caused your revenue to rise. So knowing how your customers are going to react to a price change on your part will let you know whether or not you're making more money or not, or at least getting more revenue. The increased revenue due to a higher P, again, is illustrated here. So let's go back. 200 times 12, that was the original. This whole box here was the original. You raised your price to 250. It's the demand curve here. Now this box is the original. Okay. The lost revenue is in blue and the gain revenue is in yellow. And we know from our calculations over here, revenue overall went up. You can kind of intuitively look at this shape here and say, hey, that looks a little bit bigger than this more flat rectangle. However, you may need to do the calculation in addition to the graph in examples when it's very close. And we know here, because it was inelastic, price was going to have a greater effect than quantity. Quantity only went down by 10. So we actually increased revenue by a price increase. So the area representing the lost revenue due to the lower quantity is smaller than area representing increased revenue due to the higher price. Hence, the net effect is an increase in revenue. The book talks a little bit about the knife edge case, which is not shown here, but it's perhaps worth mentioning. That's if it's unit elastic. That was if it equals 1. Remember, it was a trade for 1 for 1. In that case, an increase in price leaves revenue unchanged. The increase in revenue from a higher price exactly offsets the lost revenue from Q. So when elasticity, the only one we didn't talk about here was the knife edge case, which is known as a unit elastic equal 1. There's really no change in revenue, so you just trade 1 for 1. Hopefully that makes sense now. Elasticity in the expenditure / revenue. Let's do some examples here. Pharmacies raise the price of insulin by 10%. Does the total expenditure on insulin rise or fall? Second example, as a result of the fare war, the price of luxury cruise falls by 20%, so there's some competition in the cruise business. Does luxury cruise companies' total revenue rise or fall? Well, we need some more information. These problems are perhaps similar to those I might ask on an exam. They're complex and they can be kind of complex, but they test several skills at once. You must determine whether demand for each good is elastic or inelastic, and also must determine the impact of price change or revenue / expenditure. So far, we've been talking about how elasticity determines the effects of price increase on revenue. Part B asks you determine the effects of a decrease in price. So we've been talking about price increases. Well, it works the same way in terms of price decreases as well. All right, so let's look at the first example. Pharmacies raise the price of insulin by 10%. What do we know about insulin? It's fairly inelastic demand. People need it to survive. So does the total expenditure on insulin rise or fall? We know expenditure is simply price times quantity. It's revenue for the pharmacy. It's expenditure for people. Since demand is inelastic, Q will fall less than 10%, so expenditure rises. People will spend more money to get their insulin. That makes sense. Now looking at B, as a result of fare war, ticket wars between luxury cruises, the price of a luxury cruise falls by 20%. Does the luxury cruise company's total revenue rise or fall? Well, we look at revenue again for the company's price times quantity. The fall in price reduces revenue, but quantity increases, okay, which increases revenue. But which is bigger? That's what it boils down to with elasticity. Since demand for a luxury item like a cruise is elastic, quantity will increase more than 20%, so revenue rises. People will say, hey, let's go on a cruise instead of driving to Disney World or whatever. The first part of the explanation discusses the opposing effects of the revenue, so it's the purpose here is to clarify the effects of the price decrease on revenue. And again, we had previously only discussed the effects of price increases. So here's a price decrease on a luxury item. We talked about before a price increase on a luxury item. People are just going to bail and go do something else. In this example, really elastic demand, cruises become more affordable. Quantity is going to shoot up more than the price went down. So actually the revenues go up. So, knowing elasticity helps us understand what might otherwise be counterintuitive results. Here, we're going to talk about whether a drug interdiction increases or decreases drug-related crime. One side effect of illegal drug use is crime. Users often turn to crime to finance their habit. We examine two policies designed to reduce illegal drug use and see what effects they have on drug-related crime. For simplicity, we assume that the total dollar value of drug-related crime equals the total expenditure on drugs. And then the demand for illegal drugs is inelastic due to addiction issues. People have to have their fix. So the interdiction of the drug interdiction, the drug war, if you will, it reduces the supply of drugs. Since the demand for drugs is inelastic, price rises proportionally more than Q falls. People they're addicted, they want their drugs. Result is an increase in the total spending on drugs and in drug-related crime. So essentially, you started with this original demand, which is fairly inelastic, pretty vertical, and you had this supply of drugs. The drug war, the drug interdiction programs reduce the supply and availability of drugs, but you still have a pretty inelastic demand. So what happens is you move from this original price, okay, and this initial value of drug-related crime, and supply decreases. So what happens? Price shoots up, okay. Now you look at these two boxes. You lose this. This is the initial value of drug-related crime, and the stakes are raised. It's a higher dollar business. There's more gang-related fighting on the streets because there's more money to be made. But just how much more? How much more are people robbing people to try to pay for their drugs? Well, the drugs are more expensive. They're having to commit bigger crimes to fuel their addiction. So the new value of drug-related crime is higher. So just an interesting simplification of something that's been proven in the economic literature, that actually the drug interdiction can actually increase crime and also drive up not only the crime rates, but also drive up the cost for people who do things like rob and steal and do things to finance their habits. So the price goes up, forces more crime actually into the situation. So very interesting. Policy 2, education reduces the demand for drugs. So this is the interdiction. Now we're going to look at perhaps addressing the drug war as more of an education issue. So we educate, and that reduces the demand for drugs. Price and quantity fall, which result in a decrease in total spending on drugs and in drug-related crimes. This is a demand-related issue, okay? You had your original supply and your original demand, just like the previous example. But what we do here is we educate kids. We do just say no. We spread, more information about the exact consequences of drugs, not only crime, but also health-related. And that decreases the demand. People say, man, I'm really going to try not to get hooked on drugs. That was a lot of scary stuff that can happen. And so demand decreases. You had this original price and quantity here, expenditures on drugs. Now that is reduced down to here. So what happens? Price of drugs goes down, demand goes down. It actually shrinks the problem. So was this large pink area, which included the yellow area you see here, was the initial value of drug-related crime, is reduced to this yellow box here. So just an interesting insight into how to go about the drug war. So, all right, that was all price elasticity of demand. Now we're switching gears to price elasticity of supply. Price elasticity of supply set up very similar to price elasticity of demand. It's just percentage change in quantity supplied, before it was quantity demanded, percentage change in quantity supplied, still divided by the percentage change in price. So price elasticity of supply measures how much quantity supplied responds to a change in price. Loosely speaking, it measures the seller's price sensitivity. So before we're looking at the buyer's price sensitivity in terms of how much they would want if the price goes up. Now we're looking at if there's a price that goes up or down, how does the seller respond? Well, as a seller, remember we have to switch hats here. You're going to want more money. So at a higher price, you're going to sell more of your product, and a lower price, less of it. So again, we use the midpoint method here to compute the percentage changes. Most everything in price elasticity of supply section corresponds with the concepts that were in price elasticity of demand, so it's a little more compact here from here on out, but it's just a repeat of the same thing we just did with price elasticity of demand. All right, so price elasticity of supply, again, just given a change here where price rises by 8%, price goes from P1 to P2, and that's an 8% change. And quantity rises by 16%. So again, positively sloped. If you're getting paid more, you're going to want to supply more as a seller. How much more? Elasticity is just saying how much more. Price elasticity of supply would equal that rise over run. That 16% over the 8%, and elasticity would be 2. So that's pretty elastic, right? Now, we talked about a variety of supply curves. Listen, there's a variety, or we talked about a variety of demand curves, I should say. There's a variety of supply curves as well. The slope of supply curves closely related to this price elasticity of supply. Again, we're going to go from vertical supply curves all the way down to horizontal supply curves. The rule of thumb: the flatter the curve, the bigger the elasticity. It covers a wider range of quantity. The steeper the curve, the smaller the elasticity. It covers a smaller range of the quantity. We have 5 different classifications. Economists classify them in terms of their elasticity. Next 5 slides are going to present different classifications from least to most elastic. So here we go. Here's the one extreme. There's 2, obviously perfectly vertical and perfectly horizontal. A perfectly elastic supply curve. We have a price rise of 10%, but what do we have here? A perfectly vertical supply curve. Quantity changes by 0%. Supply curve is vertical. Seller's price sensitivity is none. Elasticity is 0. Obviously, it's an extreme example. So perfectly vertical. There's no movement along the quantity axis. So it's perfectly inelastic. It's fixed. There's no movement either way. Perfectly inelastic. Now, let's look at a fairly inelastic curve. Pretty vertical. Okay. Supply curve is relatively steep. seller's price sensitivity is relatively low. There's very little movement along this from here to here. You don't cover a great amount of, like if the price was here, and the price was here, it didn't cover a wide range of quantities. Okay. In this case, price rises by 10%, quantity rises by less than 10%. Again, these are just given examples just to illustrate. That would indicate a price elasticity of supply that's less than 1. That's inelastic. That was less than 1 was an inelastic demand, less than 1 is an inelastic supply. Here's unit elastic. Same thing as 1 for 1. The elasticity equals 1. There's an intermediate supply slope, and the seller's price sensitivity is also intermediate. Elasticity is 1. It was the 10% change in price, 10% change in quantity. It was unit for unit. You go price up by $1, you lose 1 unit, so on and so forth. So that's unit elastic is where it equals 1. Now we look at an elastic example. Now notice supply curve has moved from vertical to a little bit elastic, or relatively inelastic, to now we're getting a little more horizontal. Okay, so the curve is relatively flat. Look at the range of quantities here in a short range of prices. At price 1, you have quantity 1. Price rises by 10%. Boom. Quantity goes, price goes 10% up to the price 2. And look how much ground we covered here from between the two quantities. Quantity rises by more than 10%. That's when you know you have elasticity greater than 1. Okay, it's a very elastic supply. The willingness to supply a good or service ranges wildly depending on price. If you get a little higher price, you're going to get a lot more quantity. So let's look at the other extreme. Let's say here the supply curve is horizontal. Again, it's an extreme for a reason. You don't see this a whole lot. Seller's price sensitivity is extreme. Price changes by 0%. Quantity can change by any percent. It's infinite. So quantity can be anything. Again, extreme example. Hard to come up with real-world examples for this. Price goes down below this line, they supply nothing. Price goes above, they supply nothing because no one will buy it. Relatively, pretty much impossible to see. So the determinants of supply elasticity, the more easily sellers can change the quantity they produce, the greater the price elasticity of supply. An example, supply of beachfront property is harder to vary, thus less elastic than supply of new cars. There's only so much beachfront property available. However, you can make a lot of new cars. That's limitless. For many goods, price elasticity of supply is greater in the long run than in the short run. Elasticity in general is greater in the long run. It doesn't matter if it's demand or supply. You can change a whole lot for the long run that you can't change in the short run. In the long run, firms can build new factories, or new firms may be able to enter the market to produce more supply. In the short run, that's not as easily done. So there's more elasticity in the long run in terms of supply. So let's work through some examples here. Elasticity and the changes of in equilibrium. The supply of beachfront property is inelastic. The supply of new cars is elastic. Suppose population growth causes demand for both goods to double at each price. Quantity demanded doubles. For which product will price change the most? For which product will quantity change the most? This is one of the problems and applications at the end of the chapter we're going to work through right now. So, let's look at beachfront property. In this slide and the next, the initial price and quantity of the two demand curves are the same. Okay, so keep that in mind. The only difference is the elasticity of supply and the slope of the supply curve. So we're just changing how the supply curve is drawn. The demand curve shifts to the right, but in a parallel fashion. At each price, quantity demanded is twice as high, so the new demand curve will be flatter than the initial one. Now, in the text box containing the verbal explanation, you'll notice it says bigger impact. That's just shorthand for a bigger percentage impact or a bigger proportional impact. So when supply is inelastic, this pretty vertical supply here, remember demand is increasing, but we have a pretty vertical supply because we're talking about beachfront property. There just isn't a whole lot of it, not a lot of variability. There's only so much beachfront property available. So when supply is inelastic, an increase in demand has a bigger impact on the price than on quantity. So that increase in demand, given this inelastic supply, you're going to see a bigger change in price than your quantity, because there's not as much quantity to be varied when you're talking about something in limited supply like beachfront property. When supply is elastic, like in new cars, we have a much more flat supply curve. Demand's going to increase just like it did before. These are identical demand curves. When supply is elastic, an increase in the demand has a bigger impact on quantity than in price. Because there's a higher supply, price doesn't go up a whole lot, but you see a big jump in quantity. So there's more elasticity in new cars than there is in limited beachfront property. So, how the price elasticity of supply can vary. Supply often becomes less elastic when quantity rises due to its capacity limits. Essentially, think about a factory. There's generally excess production in a factory. However, you can reach a point where you're at max, and you literally would have to build a new factory, add onto a factory to be able to make more product. That's very realistic. That's more of a long run thing. That's why we say elasticity is greater in the long run. In the long run, you can expand the factory, but in the short run, you can only produce as much as you can produce. So this graph replicates the one in Figure 6 in the textbook. This graph's not quite drawn to scale, but when the price increases from $3 to $4, a 29% increase using the midpoint method, quantity rises from 100 to 120. Or 67%. Because 67% is greater than 29%, the price elasticity of supply is greater than 1. When the price rises from 12 to 15, which is a 22% increase, the quantity rises from 500 to 525. That's about a 5%. So the price elasticity of supply is less than 1. So you can see there on the same relatively elastic supply curve, elasticity is going to change over the long run. Again, that's a great illustration of what I was talking about with a factory not able to expand. The way I like to explain this one is as follows. When output is very low, it is relatively easy for firms to increase output. They may have excess capacity and they're not requiring a full effort from their workers. Increasing output is not difficult, so it doesn't make an increase in the price. It doesn't take much of an increase in the price to increase production. So you can get more out of your workers. You can open up another line of production when output is pretty low. However, when output is very high, it's relatively expensive for firms to increase their output further. There's little or no excess capacity for production. They're already running their factories and machines at a high level of intensity. To increase output further, they might have to pay their workers overtime. Their machines experience more wear and tear and therefore require more repairs. So at higher levels of output, it takes a much larger price increase to make firms willing to increase their output further. Eventually, firms can bump up their capacity constraints and simply firms just basically run out of room. They bump up to what is called their capacity constraints. They just get to a point where it's like, we literally cannot produce anymore. And supply cannot increase output in the response to further price increases. Of course, all that applies in the short run. In the long run, the firms can build more factories, and depending on market structure, new firms can enter the market if there's an excess demand. Real-world examples: in the peak summer driving season, gasoline demand is highest. Many refineries are producing near capacity, so the supply curve is steep. In other months, when the demand is lower, refineries have more excess capacity, and the supply curve is not as steep. So essentially, what you're going to see in terms of supply curves here, this right here is pretty flat, right? This part of the supply curve is pretty flat. Well, all of a sudden, the supply curve takes off upwards. It becomes much more inelastic. So we have a half of it that's pretty elastic, greater than 1, and a half of it that's inelastic, less than 1. So hopefully we've illustrated why that can be the case here. Other elasticities is kind of I wouldn't call it a throw-in. It's something you'll be responsible for. However, the way this chapter is set up, it kind of comes in the end. Income elasticity of demand. Again, we're not talking about elasticity of demand. We're talking about income elasticity of demand, measured through response in quantity demand and change of consumer income. So this is what we all love to talk about. Hey, if we make more money, how much more of this stuff we're going to buy? So income elasticity of demand. It's percent change in quantity demanded over the percentage change in income. So you have a percentage change in income. Hopefully, for your sakes, you get your degree and you get a percentage change in income. It'll go up. There are some things that you're going to want some more of. Recall from Chapter 4, an increase in income causes an increase in demand for a normal good. Hence, for normal goods, income elasticity is greater than 0. I'm sorry. Meaning, as you get more money, you're going to want more normal goods. So normal goods are going to be those things you consume more of when you get more money. Dinners out, electronics, that type of thing. For inferior goods, income elasticity is 0. Remember, for inferior goods, it's stuff like Top Ramen noodles. You get more money, you eat less Top Ramen noodles. Spam, that type of stuff. As you get more money, you can afford things that are actual meat from animals that you know what they are, or you can afford better meals. So inferior goods actually decrease as you get more income. So the same thing holds for income elasticity of demand. The percentage change in quantity is going to be lower than the percentage change in income if it's an inferior good. So you're going to consume less of those. It'll actually be less than 0. Now we talk about cross-price elasticity of demand. It measures the response in demand for one good to changes in the price of another good. This gets a little convoluted, but it's really simple if you think about it. Remember substitutes and complements? Well, that's where they come back in. Cross-price elasticity of demand is a percent change in quantity demanded for good 1 given a percent change in the price of good 2. Okay, so hamburgers and hot dogs, hamburgers and hamburger buns. Hamburgers and hamburger buns are substitutes. Okay. And hamburgers and hamburger buns are complements, and hamburgers and hot dogs are substitutes. So for substitutes, cross-price elasticity is greater than 0. That makes sense. You're going to trade more of one good for another if they have a substitute. For example, an increase in the price of beef causes an increase in the demand for chicken. So the price of beef goes up, beef's more expensive, you're going to go to the store, what are you going to buy? Beef or chicken? You're going to buy more chicken. For complements, the cross-price elasticity is less than 0. Okay. Example: if the increase in the price of computers causes a decrease in the demand from software. So if people are buying less computers, they're going to want less software as well. So cross-price elasticity is less than 0. If you're going to see a greater change, a greater elasticity, it's going to be greater than 0 when we're talking about cross-price elasticity. If you're not going to see if you're going to see a negative relationship, it's going to be less than 0. Some examples of cross-price elasticities that the book gives. All these are from circa about 2008, 2010, somewhere in there, where gas prices were pretty high and gas prices fluctuate. But I think by 2013 they're well above 3. Now we've come down a little bit. Price of oil's gone down, so price of gas has gone down, relatively speaking. Some examples of some headlines in the news of cross-price elasticities, just to let you know this is a very real thing. As gas costs soar, buyers flock to smaller cars. Okay. Gas prices drive students to online courses. All right. Gas prices knock bicycle sales and repairs into higher gear. So gas prices are high. People are substituting bikes for cars. They're substituting online courses from home to driving to the school, and they're buying smaller cars. So camel demand soars in India. That's an interesting one. That was from 2008. As substitutes for gas-guzzling tractors, people are farming with camels more. High gas prices drive farmers to switch to mules. Interesting. I grew up on a farm. I would much rather have a tractor, that's for sure. So, in summary, it's been a long lecture. You may need more than one time through. Definitely do the reading. But in summary, elasticity measures the responsiveness of quantity demanded and quantity supplied to one of its determinants. Price elasticity of demand equals the percentage change in quantity demanded divided by the percentage change in price. When it's less than 1, demand is inelastic. When it's greater than 1, demand is elastic. When demand is inelastic, total revenue rises when price rises. When demand is elastic, total revenue falls when price rises. Demand is elastic in the short run for necessities, for broadly defined goods, and for goods with close substitutes. Price elasticity of supply Price elasticity of supply equals percentage change in quantity supplied divided by the percentage change in price. When it's less than 1, supply is inelastic. When it's greater than 1, supply is elastic. Price elasticity of supply is greater in the long run than in the short run. The income elasticity of demand measures how much quantity demanded responds to changes in buyers' income. The cross-price elasticity of demand measures how much demand for one good responds to changes in another good. Long story short, if you have a favorite candy, say it's Skittles, and the price changes, say the price goes up for Skittles, that's going to negatively affect how many Skittles you eat, but how much? Okay? Elasticity is nothing more than that, but how much. Whether it's demand elasticity, supply elasticity, that just tells you whose hat to put on. As a consumer, price goes up, your quantity demanded goes down, but by how much? Price goes down, quantity demanded goes up, but by how much? That elasticity tells you by how much. Now, you need to know whether how to interpret an elasticity that you calculate, how to interpret an elasticity that you're given. Whether it's for demand or supply, price goes up, you're going to want to supply more. Price goes down, you're going to supply less. How much less? How much more? That's elasticity. Cross-price elasticity between two goods. Are they complements? Are they substitutes? Or how is that going to affect, how is the price of one going to affect the other? Well, if you know they're complements or substitutes, you know how to answer that question. And if you're given elasticity, now you know how to answer it in an informed manner. So very important chapter, very long presentation. Apologize for that, but it needed to be done. Hopefully this lecture has been helpful. The reading will really help you hammer it down. As always, if you have any questions, feel free to drop by or give me a call, send me a message, get in touch. I'd love to discuss it with you. Until next time, thanks so much.